Hello student, myself Nimesh Prabhakar. Welcome to Automotive Electronics lecture series. In my previous lecture, I start the actuators. So in that lecture, we have discussed about the actuator and we also discussed the two types of the actuator. First one actuator that we have discussed is the fuel injector, and we also discussed about the exhaust gas recirculator valve. Now, in this lecture, we will first discuss about the variable valve timing, that is the VVT. Then we will discuss about the valve actuator. Then we discuss about the ideal speed control. Then we will discuss about the stator motor operated valve. And last we will discuss about the brushless DC motor. So in this lecture, we will discuss about this topic. So without wasting time, we start with the first one topic. This is the variable valve timing. So what is the variable valve timing? So here we discussed about the timing of the valve opening and closing inside the engine. So mainly we know that there are the two types of the valve in the engine. First one is the inlet valve and second one is the exhaust valve. So the opening and closing of this valve operation is very important. So as you know, the valve activates the breathing of engine. The timing of breathing, that is the timing of air intake and exhaust, is controlled by the shape and the phase angle of the camshaft. We know that the valve is open and closed by help of the camshaft. And we know that the camshaft is connected with the crankshaft. So the camshaft that provides the opening and closing of the valve. Here in this figure we can see the camshaft. As the camshaft rotates, it provides the opening to the intake valve, or we can say to the exhaust valve. To optimize the braking, engine requires different valve timing at different speed. That means as we increase the speed of the car or as we decrease the speed of the car, so at that time this opening and closing of the valve timing is varied. So at a different speed we have to change the opening and closing of the valve timing. So when the REV increase, REV is a term is related with the speed. So as the speed increase, the duration of the intake and the exhaust stop decrease, so that the fresh air become not fast enough to enter the combustion chamber, while the exhaust become not fast enough to leave the combustion chamber. Therefore, the best solution is to open the inlet valve earlier and close the exhaust valves later. So in the normal operation we can see the exhaust valve opening and the inlet valve opening. So here we provide when the speed is increased, so we provide the opening of the inlet valve earlier and the closing of the exhaust valve is the later. So here we can see, in other words, the overlapping between intake period and the exhaust period should be increased as REV is increased. Now we discuss the type of the VVT. So here the first type that we discuss is the cam-phasing VVT. So the cam-phasing VVT is the simplest, cheapest and the most commonly used mechanism at this moment. Basically, it varies the valve timing by shifting the phase angle of the camshaft. Now we understand by help of this example. At the high speed, the inlet camshaft will be rotated in the advance by 30 degrees so to enable earlier intake. So here in this figure we can see the opening of the inlet valve is provided earlier by the 30 degree. The actual timing of the opening of the inlet valve we can see here the 180 degree, but as the speed is increased, so here we provide the opening of the inlet valve earlier by 30 degree. So approximately it open at the 150 degree. This movement is controlled by the engine management system, or we can say the ECU, according to need, and actuated by hydraulic valve gear. Some designs such as BMW's double vent system has cam-phasing VVT at both intake and the exhaust camshaft. This enables more overlapping, hence the higher efficiency. So here we can see the opening is also provided. That means we have changed the timing of the inlet valve as well as the exhaust valve. And the last slide we discussed only the timing change in the inlet valve. But here in some cars operation like in the BMWs, the opening, that is we have changed the timing of the inlet valve as well as the exhaust valve. Now we discuss about the valve actuators. A valve actuator is the mechanism for opening and closing a valve. Manually operated valve require someone in attendance to adjust them using a direct or gear mechanism attached to the valve stem. Power operated actuator using a gas pressure, hydraulic pressure or electricity allow a valve to be adjusted by remotely. That means we know that we can operate the valve. That means we can provide the opening and closing the valve by two types. First one is the manually. That means we can manually open and close the valve. And second, we can operate the valve remotely by help of the gas pressure or hydraulic pressure or by using the electricity. So now we discuss about the types of the actuator. So there are mainly three types of the actuator. First one is the pneumatic actuator, then second one is the hydraulic actuator, and third one type of the actuator is the electric actuator. Now we discuss one by one. So first one is the pneumatic actuator. Here we can see the pneumatic actuator. Pneumatic actuator use an air or gas signal from an external source to produce a modulating control action. That means this valve operation is controlled by help of the air or the gas signal. The actuator receives the force of pneumatic signal through a top port. Then it distributes the signal across the actuator's diaphragm. As a result, the diaphragm extracts pressure on the diaphragm plate. This moves the valve stem downward in a way that to stop the control valve. So this is the operation of the pneumatic actuator. Now we discuss the second one type of the actuator, that is the electric actuators. So the electric actuators are motor driven device. They use the electrical signal that can help create a motor shaft rotation. This movement is converted into a linear motion which helps to drive the steam in the valve for flow modulation. So here the electric signal is used to operate the motor, and as the motor is rotated, the valve is open and closed. And last one type of actuator is the hydraulic actuators. So the hydraulic actuators are similar in operation to the pneumatic actuator, except they use fluid, hydraulic oil as the signal fluid to control the action of the valve. So the hydraulic actuator operation and the pneumatic actuator operation is the same. The difference is that in the pneumatic actuator, it uses the air and the gas to control the action of the valve, and here the hydraulic actuator uses the hydraulic oil to control the action of the valve. They are used in place of the pneumatic or the electric actuator valve when the force required to move the valve steam is high. Now we discuss the next one topic is the ideal speed control. Ideal speed control is an important element of the control strategy for any engine management system, or we can say the ECU. Many systems are fitted with an ideal speed control valve that provide a supply of air that bypass the throttle valve, while other systems may make use of the electronic throttle control. So here in this figure we can see this is the throttle body and this is a throttle plate, and here this is a passage where the air is entered from the air filter, and this is the air goes to the engine side. So when the person or the driver is not pressing the accelerator, at that time this throttle valve, or we can say the throttle plate is closed position. So no air is entered in the engine. So at that time engine cannot work. But actually in the practice, when the accelerator is not pressed by the driver, but engine is also still in the working position. So air is entered in the engine by help of this second one passage, and this passage is the ideal speed control passage. So air is entered from this passage, and this is the valve. This is the ideal speed control valve. So two types of the valve are used to provide a computer controlled ideal air supply. First one type is a stepper motor operator valve, and second one is a solenoid operator valve. We know the function of the solenoid operator valve. So now we discuss only the function of the stepper motor operator valve. So the figure shows a simple arrangement of the extra air valve that is built into the throttle body of some petrol injection system. The ECU pulse the transistor base in the correct sequence so that the stepper motor moves the air valve to provide the correct air supply for any given condition. In addition, other sensor signal will enable the ECU to provide the correct amount of fuel to ensure that the engine continues to run smoothly. So here we can see the figure of the stepper motor with this is the connector that is used to connect to the ECU. The multi-pin connection is typical of the type of the connection that is used to electrically connect the stepper motor to the ECU. The stepper motor can normally be checked by operating it with the diagnostic tool connect to the serial communication port of the ECM. Now we discuss the last one topic. This is the brushless DC motor. Now the first one question come in our mind. What is brushless motor? A brushless DC motor, and is also known as the BLDC, or we can say that the BL motor is the electronically commutated DC motor which does not have brushes. The controller provides pulse of the current to the motor winding which control the speed and torque of the synchronous motor. Now we discuss about the construction of the DC motor, or we can say brushless DC motor. So in this motor, the permanent magnets attached to the rotor. The current carrying conductor, or we can say the armature winding, are located on the stator. We can see two parts, stator and rotor. To convert electrical energy into the mechanical energy. Now we discuss the working of the brushless DC motor. BLDC, or we can say brushless DC motor, work on the principle similar to that of a brush DC motor. The Lorentz force law, which states that whenever a current carrying conductor placed in a magnetic field, it experiences a force. As consequence of reaction force, the magnet will experience an equal and opposite force. In the BLDC motor, the current carrying conductor is stationary and the permanent magnet is moving. When the stator coil gets a supply from the source, it becomes electromagnet and start producing uniform field in the air gap. Through the source of supply is DC, switching made to generate an AC voltage waveform with trapezoidal shape. Due to the force of the interaction between the electromagnet stator and permanent magnet rotor, the rotor continues to rotate. So this is the working of principle, or you can say how the stator motor, brushless DC motor work. So in this lecture we have discussed about first one, variable valve timing. Then we have discussed about the valve actuators. Then we have discussed about the ideal field control. Then we discussed about the stepper motor operated valve. And last we have discussed about the brushless DC motor. Thank you. Hello and welcome to our channel Electronics and Communication Engineering. Congratulations to find us for learning. You are watching a lecture session on automotive electronics that has approximately 15 sessions and more are coming up. We have more than 1200 sessions in various lecture series on courses for electronics and communication engineering. Watch it and learn. If you like it, share it, subscribe it and press bell icon to receive all updates on new session. Enjoy learning.